also going to take off my mask because there's nobody else in the room now. Had to have it on when somebody else is in the room. Change this to narrow beam. Make sure that this is headed down the track properly. And now check the angle. Now you want to do this twice. You want to do it at 5 degrees and you want to do it at 10 degrees. Okay. So I level this out. It looks like it's a little bit on the high side. Okay. Probably can't see how much I'm dropping this, but I'm really not dropping it very much. Okay, so we're ready to go now. I'm going to record my last data, all right? Put that, either on a thumb drive, take a picture of it, send it to myself, whatever. And the next thing I'm going to do is clear this and have it set for my next measurement. Now, when I was dropping the ping pong ball, it was falling at an acceleration of 9.8 meters per second squared. Now that I do this card, it's going to be much slower than that. The acceleration is going to be g times the sine of the angle. Is that 5 degrees? So it'll be g times the sine of 5 degrees. We'll see how good a result I get from that. Okay, so move the card up. I don't want to move the card up too much. Get ready to record. Release. Okay. First thing I notice is I have my parabolas back, but they're not as steep as my other graph. Okay? Well, that makes sense because I wouldn't expect that. Let me just move this down. I wouldn't expect that the same slope because our acceleration due to that sine of 5 degrees is going to be less. I also noticed that this graph isn't as steep as it was before. I'm also going to move the time down here. Okay. Move this. Again, I select or I highlight the data that I want to look at. I'm going to move this box out of the way. And try to get as many data points as I can without going to any part where it's curving. Okay. So now my data selection tool has grabbed a big part of that line right there, and it's going to give me the acceleration. Acceleration, 0.811. Okay. How to figure out what the sine of the angle, the sine of 5 degrees gives me when I use that with G. But really, this is a very short, straightforward experiment to do. You got the measurements of the falling object, you got the measurements of the inclined plane, once at 5 degrees, once at 10 degrees. All the data is collected for you. The important piece of information is the straightness of our velocity versus time graph and the slope that you get for each run. Okay? That's it. Again, I'll change this to 10 degrees. I'll raise this up, run it again, but that's pretty much the experiment.